Hi everybody, this is the Good Math Guys, Mike and Sean, back to show you how the four methods for multiplying multi-digit numbers are all tied together. They're connected. Starting out with the area method, Sean showed you that you created a box, split it into four sections after expanding the multiplicand and the multiplier. In other words, 24 is really 20 plus 4, 30 is really, 32 is really 30 plus 2. And then we simply did a grid multiplication to wind up with the individual partial products that you see listed right here, at which time all we had to do was add those together to come up with our product, 768. Similar to that, where we didn't have to draw the box, was total partial product, where your students or your kids have to know that here we're multiplying ones, here we're multiplying ones times 10, so that's really a 2 times 20, which is 40. Here that we're multiplying 30 times 4, which is really 120, which is what we've gotten right here. And here we're multiplying 30 times 20, which is 600, which we've got right here. Very similar to what we did with the area method, but this a bit more traditional. All we had to do then was add these four partial products up and come up with the same exact full product, which was 768. Then we went to traditional partial product, which is the method that you're most likely to find in an elementary textbook. What this method did was something a little bit different. And I might ask students, if I were doing this on a board in a classroom, I would ask them if they looked at this 48 and saw that 48 somewhere over here. And it doesn't take very long for them to say, well, this 48 is a combination of that 8 and that 40. And then I'll say, well, do you see the 720 anywhere over here? And almost immediately they'll respond by saying, well, the 720 here is a combination or an addition of the 120 plus the 600. So what traditional partial product does is it compresses these four partial products here and here into two. But there's a trade-off. Some kids don't have good experiences to begin with this trade-off, because all of a sudden now we're into having to regroup, and all of a sudden we're into a situation where it's important that students know the mathematical reason for why that zero appears there. I can remember when I was a kid in school, a teacher just told me to plunk a zero in there, and what it did was it pushed this 2 over where it belonged. But if we really examine this more closely, this is a 30 times a 4, which is 120. So we record the 20 and regroup or carry the 1. So that's a bit of a trade-off. As far as lattice is concerned, all of these partial products are in this lattice square. In other words, the 8 in 1's place. There it is right there. In this square, 4 in 10's place gives us that 40. And in this square right here, the 1 in 100's place and the 2 in 10's place gives us our 120. And in this square right here, the 6 in 100's place gives us our 600. So you can see that all four of these methods are connected, and that's one reason why Sean and I subscribe to the idea that after teaching all four methods in a classroom, we say to the boys and girls, okay, now it's time for you to decide on which one you like the best and go with it. That being said, for now, this is the Good Math Guys saying we don't have any more in this particular video, so bye-bye.